We continue the discussion on shear force diagram in this video. Let's see how we can create a shear force diagram for a force system where you have a uniformly distributed load and a point load. So what you have here is a uniformly distributed load, which I have shown like this, and you also have a point load. So you have a point load here, and a uniformly distributed load. Let's call this load as 100 kilonewton and this as 10 kilonewton per meter. So you will have two supports at either ends, one a hinged support and you have a roller support. So the total length of the beam, let's say 10 meter, and this is over a span of let's say 3 meter, and you have a 4 meter here, and you have 1.5 each. A and B. Now in order to calculate the reactions at A and B, you will need to construct an equivalent diagram for this force system. How do you create an equivalent diagram? An equivalent diagram is nothing but all the forces are shown as a point load. So how you can create a uniformly distributed load, or how you can convert a uniformly distributed load into a point load, that is the main thing or main topic of this discussion. So whenever you have a uniformly distributed load, you can calculate the total load of that UDL is equal to 10 kilonewton per meter over 3 meter. So 10 times 3, that is equal to 30 kilonewton. And for a UDL, the entire load of the UDL, which is 30 kilonewton in this case, will be acting at the centroid or center of gravity of that force system. That means that 30 kilonewton can be considered as acting at the midpoint of this span over which the UDL is acting. So you can convert this force system into another one, into an equivalent one like this, where you have your beam, and what you do is converting your UDL into a point load. So you have one point load here and you have another point load here. So the distances will be 1.5. This is 1.5 plus another 1.5 here, so this is 3, and you have a 1.5 and a 4 here, so this is 5.5, and this load is 30 kilonewton, and this remains the same at 100 kilonewton. Now you can calculate reactions at A and B. We apply our equilibrium conditions, which are summation of forces in x direction equal to 0, summation of forces in y direction equal to 0, and summation of moments about z direction equal to 0. This is 0 because there is no forces in x direction, and now you have this equation will give you RA plus RB is equal to 100 plus 30, which is 130 kilonewton. Now the moment equation will give you another set of formula where you have to take the moment about, let's say moment about A. Moment about A will give you have three forces, RB, 30 kilonewton and 100 kilonewton. RB is acting upward, 30 and 100 acting downward. So this will have a moment opposite to the direction of RB. So let's call RB at 10 meter from A. So 10 RB minus 100 kilonewton at 1.5 from A, so 100 times 1.5 minus 30 times 4.5 equal to 0, or 10 RB is equal to 150 plus 30 times 4.5, which is equal to 135. That will give you 285, or you have RB is equal to 28.5. Now you substitute the value of RB back in here, and that will give you RA is equal to 130 minus 28.5, that is equal to 130 minus 28.5 is equal to 101.5. So you have RA is equal to 101.5. Now that you got the reactions at A and B, you don't need this diagram anymore. You can go back to your original diagram where you had a UDL and a point load. Now let's go back to the original diagram. You have your UDL over a span of 3 meter and 4 meter, and you have another point load of 100 kilonewton at 1.5 meter and 1.5 meter A and B. This is 10 kilonewton per meter. Now you have RA and RB. So RA is equal to 101.5 and RB is equal to 28.5. Now in order to construct a shear force or a bending moment diagram, we will discuss the bending moment diagram in a later video. In order to construct the shear force diagram, the easiest way is to consider the beam in sections. Now when you consider a section of a beam, only consider what is remaining in the section. Don't consider anything at the other, only consider one side of the section, don't consider the other side. I will explain it in as we go along. So when I say consider a section, let's try if you can create the shear force diagram for this force system. First you decide where to start. You can either start from B or from A. Let's start from B, and between any change of force you take a section. So in this case at B you have reaction, and at 4 meter distance from B you have the UDL starting. So you take your first section between point B and this point here. So you have let's consider a section like this. You have your RB which is acting upward, and you have a section here. You have taken a section of the beam. Let's call this excuse me, XX, and let's call this distance X. Always remember, when you take a section, the maximum distance of X is the maximum distance of this section. You take the section from B to this distance, so the X value will vary from 0 at this point and 4 at this point. So at X equal to 0, you can see the only force is the reaction force at B. So the force at X equal to 0 is 28.5, and as you can see, as you move along the beam, there is no other forces. So at X equal to 4 you will have the same force. There is no change whatsoever in the force. Now that one section is completed, so that is your section 1. Now you move on to the next section, where you take your section in between this point and this point. So you will have RB and your UDL starting somewhere here, and you take the section here, again XX. Now you can consider this distance is already completed, so you can take the X here. Again In this case, the x will be varying from this point to this point. So the minimum value of x is 0 at here, and the maximum value is 3 at here. Now at x equal to 0, again the force is 28.5, which is carried over from here, and at x equal to 3 the force is 28.5 plus the total load of this UDL, which is 30. So you will have total load of 58.5. Oh, that's a mistake, because what happens there is 28.5 is acting upward, whereas 30 is acting downward. So at x equal to 3, the force will be 28.5 minus 30. Why is it minus? Because 28.5 is acting upward and 30 is acting downward. So you will have 28.5 minus 30, which is minus 1.5. So that is equal to minus 1.5, which means there is a change of direction happening to the force. Now you take your section between here and here, because you have another force acting here. So your section should be in between these two. Now what happens at that stage? Let's draw that section here. You have RB, you have your complete UDL here, you have your 4 meter here, and you have your 3 meter here, and you have your section here. So this is your x. Now remember, x varies from 0 to 1.5, and there is no change in the force in between these two sections. So your force will remain the same between those two sections. At x equal to 0, force is minus 1.5. At x equal to 1.5, force is minus 1.5. So in that section no change happens, and you consider the last section now, which is like this. RB, you have your force over 3 meter, and you have your 4 meter, and you have your 100 kilonewton load here. This is 10 per meter, and you have the section here. So this is 1.5, and this is your section x. Now here you have 1.5 just before the 100 kilonewton is acting. So in this case, at x equal to 0, you have force is 100 kilonewton acting downward in the same direction of the previous force. So minus 1.5 minus 100 Newton. So minus 1.5 minus 100, which is minus 101.5. And at x equal to 1.5, you can say there is the reactional force there. So let's consider that later on. At x equal to 1.5, let's say that is minus 1.5 again, 101.5 again. Now you can create, you have completed all the sections. Now you can create the shear force diagram for this force system. When you complete the shear force diagram, you will get a complete understanding of what we have done. So let's complete the shear force diagram. For that, you need a datum line. I'm just drawing a datum line here. So that's your datum. Now your first section, this was your first one, and this is A, this is B. So at A, at x equal to 0, the first one, this is your first, second. So first point, you have 28.5 kilonewton acting upward. So you have 28.5. The magnitude is 28.5, and at the second point, at this point you have the same force. So until the point 4 meter you have the same force, so there is no change whatsoever. Now you move on to your second system, where you have first point you have 28.5 again. Remember, this second and the second are the same, and at x equal to 3 you have minus 1.5. so when you move to the distance at 3 meter, you will change from here to here. This is a straight line. I'll just, because for a UDL it will be a curve, it will not be a curve, it will be a inclined line. So from a maximum value of 28.5 here, you move to minus 1.5 at this point, and then what happens is you have the third section where you have at x equal to 0 and x equal to 1.5 meter you have minus 1.5 kilonewton in both cases, which means you remain the same force until you reach the distance 1.5. so minus 1.5 remains the same. This is 1.5 meter, and at this point you have another force which is 100 kilonewton acting downward, so you add that 100 kilonewton to the minus 1.5 in the third state here, so the force is minus 101.5. so you have another force coming down to minus 101.5, and until you reach the end point, which is A, you keep the same force because there is no other force at in between these 2 points. And you can see your reaction at A is 101.5 kilonewton. So that is a positive force. So what happened here is this will go back all the way to A, because the magnitude of reaction RA is 101.5. So this is your shear force diagram. Now an interesting point I'm trying to make here. When you draw the bending moment diagram, the bending moment will be maximum at a point where shear force is minimum. So on seeing this diagram, I can say the bending moment diagram for this force system will have a maximum bending moment at this point, where shear force is equal to 0, bending moment is equal to max. We will see that in the next video. I hope you enjoyed this, and this is a clear explanation. Any doubts, please give feedback on the channel or on this video. Thank you.